Welcome to day 3. We got a great first day 3 presentation coming up. He just burns me up. All right. I'm fired. Ed Fronaphel and I go back maybe 30 years or more, a long time. He's a structural engineer that actually has a personality. Okay, I know you've heard that before. Ed deals with buildings that have problems and just trying to fix them. And one of the things that I'm most concerned with, and Ed is very concerned with, is how buildings perform from a fire perspective. And things have been burning a long time, and you'd think that we have a real understanding of fundamental performance of fires, but you actually can't figure stuff up unless you burn stuff. Not your client's stuff, but you know what I mean. And so it gives me tremendous pleasure to introduce you to him, and I'm looking forward to fires because it's one of the things that is fundamentals have not changed, but the materials and the assemblies have changed dramatically, and we as professionals actually have to know about it. Ed, take it away.
All right, thank you, Joe, I appreciate it. All right, so I'm gonna start with a couple of things. So first off, my name, there's nothing silent. And I guess I gotta start this here. So there's nothing silent in my name. So everyone say it. Fronaphel, right? Apfelstrudels. You know what Fron is in German? F-R-O-H-N, pleasant. So think of me as the happy apple. Easy way to remember it. All right, so that being said, we're going to talk about construction defect litigation is where this starts. And as inspectors, as engineers, as architects, as builders, something we have to know is what tolerance are we allowed in fire assemblies? The answer is none, right? That's what the code says, no tolerance. You build it exactly as it was tested. How many think that's ever happened? All right. Oh wait, I got one. So we're going to talk about that. I also want to do one other thing is we're talking about collaboration, and we're talking about organizations like this where we come together and we consistently meet, talk, discuss. And what happened pre-COVID was Robbie Schwartz and I were in a hallway. I was presenting on the exciting life of expansive soil and lateral loads. I don't remember what Robbie was doing because I didn't go to his. But we were in a hallway and we were talking about the litigation. We're seeing claims on townhomes between about $20 to $50 million per property for construction defect litigation specific to firewalls. And I'm half plaintiff, half defense, so I work for both sides. So I was at a quandary, what do I do? Because I have to have the perfection of the code, at the same time I have to have my client in mind, my contractor, developer, builder. And is this doable? So first off, Robbie, stand up. Could I get a round of applause for him? If we have time, I'm going to get to his slides. If I don't, we don't, but they're uploaded. And we're going to talk about the interdisciplinary needs between the energy people and the structural civil architects. And it was a very important conversation, so I want to make that. I've got one other housekeeping I want to know as I've been talking to the crowd. How many in here are under 25? Stand up, stand up. Okay, let's move it up. We're going to move it up one notch. How many are under 35? Stand up. And now, how many are under 45? Stand up. That is awesome. Our industry, you guys are what's coming up in the industry. That's why I say that, right? And I stop at 45 because the rest of us are old, right? We're done. So we don't count anymore. So thank you very much, and thank you for attending. And for everyone over 45, you know what our job is. To make these people great, period. That's our job. So always have to push that. So let's get into this. Schedule-wise, I'm going to throw it up. You can ignore it because I only need one slide. I've got 141. So we're going to see how far we get in this, right? But we're going to talk about a couple things. We're going to talk about the history of passive firewall construction, the reasons for it. We're going to talk about the alleged, right? Nothing's proven, the alleged effective work. And then we're going to talk about the testing. In combination with that, we're going to talk about the interdisciplinary needs between all of our professions and how it relates to firewalls, specifically the shaft wall assemblies. So collaboration trades as the end product, applying the provisions of a 2-hour wall, understanding the observation criteria that we, particularly if you're investigating or you are quality assuring, only the contractors adhere to quality control. The rest of us just assure, right? That's it. We don't look at everything. And then understanding which are the impacts of those critical tolerances. And we'll talk about what we found in the testing. So the basics of fire, I need 3 things: oxygen, heat, and fuel. So the first thing I could do to avoid a claim is what? I could build in outer space and make sure there are no tenants, right? If I want to build, Joe talked about the perfect wall. As an engineer, I'm going to build a hoop because I like hoop stress. I'm never going to build anything with corners. My windows are going to be round. And I'm not going to put any doors in because then nobody enters it. And I am good to go. Right? No tenant, no lawsuit. I can be there. But really what we're after is oxygen and heat and fuel source. And the oxygen in regards to the 2-hour wall and in regards to energy ratings and fire blocking. That's really where we're going to spend a lot of our time today. So we're going to do this as a forensic engineer. And we're going to look at 2 things under NFPA 921. Now, you'll see a lot of codes come up. You'll see manufacturers come up. Everything on here you can get. It's all public except my testing. And you'll get some of my slides and my testing if you download the presentation. Everything else you should be able to find line, nothing proprietary. So you'll see manufacturers' names, products we tested, anything you can get, right? Except for my testing. You'll have to talk to my clients about that, on that. But I want to show it to you. So inductive reasoning is based on empirical data the investigators collected through observations, knowledge, training, and experience. So that's where we start this. And deductive reasoning, differently, does not have a valid or reliable conclusion unless the hypothesis can stand the test of careful and serious challenges. Right, so in the courtroom, we can't have ipsy-dipsy. I can't go in there and say, this is my belief, and therefore it's true, unless I'm Joe. Joe can do that. But Joe's is backed up with years and years of testing, right? So we need to be really careful where we go with that. And we want to prevent confirmation bias that's formed solely on the supporting data of that. So we want to be really careful. So we're going to get to the firewall. And this is an interdisciplinary requirement, not just the architect. So I, as a structural engineer, I have to be concerned with the structure. We're going to talk about that. Why does a civil engineer matter to a firewall? Property lines, easements, party wall agreements, and topography. Topography matters to a firewall because if I have townhomes and I step up, first off, in the post-tension slab design, who thinks I can design that step with a standard post-tension package? Is that in the black box? I just punched in some numbers? Not a chance. Once the step is there, it's a whole different process. So if I have a sloping site, these party walls become very problematic to me. Obviously, the structure. Is the party wall, the 2-hour shaft wall, structural in a townhome? 100% complete structural independence. It is not structural except for itself, unless there's a fire. Now it becomes structural again. And we'll talk about the reason that becomes important to that. Mechanical, plumbing, electrical, is it allowed in a shaft wall? It'd be tough to get in that 2-inch shaft wall, but I can put what I call the beauty wall on either side, right? The drywall in my kitchen, my walls, my floors. I can now put that plumbing, electrical, and mechanical into that space. Right? So the idea of the 2-hour separated walls was nothing in them. Shaft wall gives me the viability to work on that side. And lastly, sound. Right? This is great for sound. Fabulous wall construction. And remember, we design for sound and we get sued for noise, as you heard yesterday, I think it was, right? Design for sound, sued for noise, right? You don't want me with my voice as your neighbor, by the way, right? Ask for an upgrade. All right. So we want to do this under the UL fire rated assemblies. And as I mentioned, if I open up the orange books, and every contractor has the orange book in the trailer on the site, right? And the architect copies the orange book and puts it on their plans, and there's always a set of plans on the site, right? And every subcontractor has thoroughly reviewed the plans that were on the site and has their own copy of the plans, right? Yeah. I live in a perfect world. It's really nice where I live. Doesn't happen, right? So we're going to look at that combination, and really we fight over, and I'll show where the graphic comes from that tested fire rate assembly. And we're also going to look at the building envelope and air tightness across this shaft wall and some of the impacts of that. Again, I thank Robbie, because I learned so much as he went through it about things I was missing as inspector, by the way, because I'm there as a structural engineer. I'm not there to look at your energy. Not my job. But it ends up it was my job. I just didn't know it until I was told. So now I know. So there's been a couple studies done. We've heard some of these people on this, and I want to bring this up, and everything's online. You can get the links on there. Thrive Home Builders out of Colorado, one of my clients for a while, and then they looked at doing the buildings. We're going to talk about some of those findings and how they interprocess to that. And that guidelines there, townhomes, obviously an important part of our housing market, particularly with affordability and making sure everyone under 45 can buy a house just like we did when we were under 45. Like, we'd like those days back someday. Hopefully we get there. And we look under those townhome area separation walls, in this case under construction, how they work, what they do. So I won't get deep into this, but I want to make sure it's clear this is an interdisciplinary topic. Something we should all be concerned about and all pay attention to. Now, the 2-hour wall assembly was a pretty decent assembly. Make sure I can do this right here. So this assembly, I remember how to get to the laser here. It won't react? Oh. But I can't do that. All right, we'll get there. So let's look at the 2-hour wall assembly, right? Our standard 1-hour wall. And this is what we're going to replace it with. So we used to build this. Now this is great for the civil engineer. Why? I have a 1-inch airspace. Where do I draw my property line? Right down the center of the airspace. And then the contractor, what's the tolerance of the property line in construction? ½ inch. Plus minus ½ inch. I can be ½ inch this way, ½ inch this way. I'm still in the airspace. Right? Who owns the structure? In a townhome, who owns the structure? No. The individual owner is buying property. In a condominium, who owns that? The HOA. They're declaring it first, and it's transferred to the HOA. So we have to understand, are we building individual property, or are we building common property? We also have now party wall agreements. Party wall agreements are going to make this tougher. Who manages the party wall? Tenant A and tenant B and tenant C. So you only want to buy an end unit, because then you only have one to deal with. If you're buying an inside unit, you have 2 party wall agreements. So if something goes wrong, you and your neighbor are talking. Right, so a lot of things to think about from that side. And we're after this 2-hour rated assembly. How far above the roof does the 2-hour wall rated assembly have to go? The answer is right here, but 30 inches or 4 feet. Right, in the 97 building code, it was 5 feet. Where'd that come from? Because nobody puts their trust at 5 feet. Well, that was civil engineers with 5-foot separations and architects with 5-foot separations, 10 foot between, right? but now it's 4 feet or 30 inches. Now I mentioned if we step the foundation and the neighbor's unit goes 18 inches higher than mine, do I have to extend the 2-hour wall vertically? Just 1 hour, because now I have property to the side with no building, right? So there's a lot of things we want to think about as we go through this. The Gypsum Association, thank gosh for them, they put together some great publications for us, and they show us how to build this with this one detail, but no step, right? So we note up at the top of this, it says roof trusses. The wood frame truss. Now below that, we can see the party wall, the beauty wall as well, the beauty wall being the drywall with the studs I hang my photos on. What do I do in the attic? Do I have to put drywall in my attic? Okay, a show of hands who does not believe I need drywall in an attic. Boy, not one hand up went up. So how come every time I inspect a property, every time, I have no drywall in the attic? All right, well, I'm glad no one raised their hand. We're going to have a little conversation about this. Right?
But I see the whole set of people treating the wires made it.
Yeah, secondary mechanical, electrical, and plumbing. Keep them out of my structure. Keep them off my drywall. Everyone should like exposed MEP. We need to change the industry. Right? Everything should be exposed. It's easier to maintain. Right? When the water leaks, the pipe's right there. Perfect. So we'll talk about that roof truss. We're going to talk about the area fire separation wall. We're going to talk about the fire blocking and floor lines and the foundation. Now, when I look at this GA 620, what am I testing at the lab? So I get a UL designation for a shaft liner. I look at this. What do you think got tested? An assembly got tested. This is not that assembly. All right, we're going to talk about some of those in that regards. Now, NFPA 221, very important. It really helps in an understanding of how these firewalls get put in. Good illustratives. It's not just the building code, not just the manufacturer. So if I'm on a forensic setting, why do I care about all of this information? Standard of care versus standard of practice. Standard of practice, the argument is, well, I do it because Lisa does it, that's how Jen does it, so I'm going to do it the way they do it, standard of practice. Standard of care is what you should have done, not what you actually did or what others do, what you should have done. So all these codes matter. We have to have that education as we put these together to make sure we've done it. A nice way to think about that is if everyone's driving 90 miles an hour and we pass the trooper and I get pulled over, can I say, well, I was just doing what everyone else did? Probably, I could, but you know, I could definitely try, right? So we're going to move to this 2-hour separation wall, and we open up the manuals, and it shows that floor line connection. Again, was that tested? The answer is no, that's not tested, right? Standard construction practice, we have the shaft liner wall, which was tested. We have fire blocking, we have frame, and we have the beauty wall. The beauty wall being, again, where I hang my photos, my term, but that skeleton wall with drywall. And so we look at that. Now, how much, if I'm building on a foundation in a townhouse, how much movement am I allowed from the structural engineer? Simple answer, by the way. None be awesome, but that's expensive. Only in nuclear power plants, right? Well, it's enough that it doesn't damage the materials, and it's not perceivable. What's every engineer's favorite answer? It depends, right? It depends on the finish, the client. Can they afford hourly attorneys, or they do need contingency attorneys? Right? If they can afford hourly attorneys, my tolerances go up, right? If they can afford the attorney, they can afford a better house or a better office building. So what happens with that is we're seeing movement at that step where the slabs flex, and it's opening up the firewall, the airspace. What happens to that fire blocking? it falls to the bottom. So I need to talk to the structural engineer. If I have a 30-foot high townhome and I'm 30 feet from each slab edge and the slab edge drops 2 inches, what happens 30 feet up? 30 feet, 2 inch, 30 feet, 2 inch, right? The whole thing racks. So the fire blocking will drop, guaranteed. So we want to be thinking with the structural engineer. I can't just put the wall in. I can't just put the drywall in and consider. Now, if I figure out how to attach the drywall, it'll still open the space up. Is it still fire blocking? No, so I better talk to my rock wool guys, right? Maybe do something a little different here. So we'll work through that. We're going to look at the assembly itself, the C-tracks, the liners, the H-studs, the gypsum. We want to look at, and the manufacturer should be providing these details, or the architect. So I can open the manual up. I got the roof junction detail, roof parapets, exterior wall junction, the intersection detail, the foundation detail, and the floor, right? The recipe's there. So the architect shouldn't have to draw it, but can the architect just throw this on their plans and then put their stamp on it? No, the architect has to review every detail and accept the detail before they stamp it. Responsible charge. Or the architect can say by others, right? Bring all manufacturer installation requirements to the site and follow those. Is the architect still potentially responsible if they're wrong? Probably, but at least the manufacturer might be with us, right? And one thing we found with this, the manufacturers, I'll put them up, we did not find an issue with the product, so I'll start there. These shaft liners in my tests worked. And that's a really good sign for everyone, right? That I can repeat that. So the Gypsum Association starts off and they tell us, always use back-to-back C runners between courses and gypsum area separation walls. Do not substitute a single H stud for specific back-to-back Cs. So this is in the horizontal, I cap it. I start my next sheet up. Why don't I want to use an H? I'm a structural engineer. What do I like about the H? It's structurally solid. How's the C's put together? They're screwed back to back. They're not as rigid. Right? So personally, as a structural engineer, I'd say, well, I think an H is better. But will the H track vertically fit in the H track horizontally? With a little bit of bending. Right? A little bit of bending. So they tell us not to do that. They do tell us to put the code fire blocking on each side. And at the top floor, the firewall may either extend to the top of the parapet or terminate under the roof deck. And then if it terminates at the roof deck, we do the 4 feet horizontal. Right? So some things to think about. Sound, I've got my 2-hour rating, great sound SDC, 65 to 69, which means in the field I'm allowed what? Quiz from yesterday. Not by code. Code allows a 5-point reduction. Construction tolerance for sound. Right? So the code does tell me for sound what I can achieve. So I can lose 5 points in the field test and I still pass. Now on the 2-hour rating, I noticed the sound test is 35 to 39. That's the tested assembly. Right? What's the minimum tested assembly in the building code? Lots of quizzes today. 50, right? That's my dorm room. Minimum standard of the building code, 50, which means I could test at 45. So the shaft wall on its own, not a chance. It's not going to meet code for sound. So I need the beauty wall on both sides to achieve that. And again, it does a very good job with that. Now that beauty wall, does that help my fire propagation or minimize my fire propagation? 5/8-inch drywall, studs at 16, insulation, airspace. That's a big help to my firewall, right? That has to burn away before we get to the shaft liner. And we'll talk about how that occurs. Now, they also show me that intersection at the parallel roof truss. We show the shaft liner. We have our aluminum clips. What don't I have up there? Drywall. Now, but if we look at the one on the left, from the gypsum, I am required to have a FireGuard C interior panel over the H stud or over the C. So how many have seen that done? I've done this a long time. I've seen it done in repairs when we don't have clearance. We're going to talk about the clearance. There's also an exception to that that says accessible attic. So we're going to talk about some of the accessibility needs. So we're going to go back to the energy code and we're looking at the compartmentalization on this. And we'll talk about the guarded and unguarded. And I do this because, again, I'm trying to tie the energy people into the structural civil architects, everyone else, right? We have to be working together. So we want to look at this, and you've heard over and over about the CFMs per square feet, all the testing that's done. Same as the condominiums, right? The condominiums, the difference by compartmentalization is the airspace, and the HOA owns everything else. So if I'm hired to fix one of these or look at it, I probably should know, is this condo, townhome, or party wall? Because if it's party wall, I'm going to have the agreement between all the neighbors, no HOA. If it's condo, I only have one client. If it's townhome, I might have three. Property owner X, HOA, and property C, right? The condo, I'm just dealing with the HOA. I don't care about the owners because you only own your airspace. Right, we already said we were taking all the windows out, so there is no air, so I don't have to worry about those people. They're done. So we look at that, and we start looking at each of those assemblies and the location, so we can see on the middle, we can see the vertical H running up. We can see the C runner at the base of the foundation. We can see the back-to-back Cs at the horizontal joints, and then the clips at the structure. And what we're after is that complete assembled system, free of holes and breaches, right? So just so everyone kind of knows the pieces we're looking at. We get in the attic, and now Gold Bond does these great installation videos. So I put them here. If you just want to watch it ground up, actually most of the manufacturers have these now. If you're speccing these, watch their videos. The manufacturers have done a fabulous job of how to do this right. They really have, right? I go to court and they'll bring in this animator and they do an animation of how to build a wall. And my comment is, well, I can just click play on the YouTube. You paid $45,000 for an animation? I can just bring the YouTube and click play for the jury. Pretty simple. But the animators make good money. So if you're an animator, keep doing it, right? Keep doing it. And then we look at that. We don't see in that detail any gypsum in the space up above, and that's normally what we see. We also see that gable end truss. Structural engineers, what's important about the gable end truss if the townhome units are required by code to be structurally independent? Where's the diaphragm? That's the roof sheeting. So if it's structurally independent, each side of my townhome, and I have lateral load, how's it get to the foundation? Through the gable end truss. So that truss has to be designed to take the full unit's lateral load, transfer it to the top plate, transfer it to the rim joist, transfer it to the beauty wall, one more floor down, all the way to the foundation, and then the soils get it. Right? So if I walk in an attic and I don't see diagonal members, should I have some concern? Yeah, right? Who can design a frame wall with no sheathing and let the wind blow on it? Maybe so, right? So we should be looking at that. What is the structural independence at that gable end wall? Now, that means I have to add one more player to this equation. What's the structural engineer do once we get to the top plate? Buy others. That's the truss guy's issue. And the trusses are a deferred submittal. Who's in charge of the deferred submittals? Ultimately, owner, yeah, contractor, and then who has to coordinate pursuant to the International Building Code or the International Existing Building Code? The designer in responsible charge has to be designated, and it's their job. The designer in responsible charge. It's in the code. It doesn't say engineer, it doesn't say architect. It says designer in responsible charge. So somebody has to be designated on the project. to handle all of that. It's not the building official, and although the general contractor should be coordinating it by code, it's who's assigned. What if I'm a design build firm? What if I'm a design build firm? The code has an exception that I, as contractor, can be my own designer and responsible charge. So that is allowed. So some things to think about. So everything's next to each other. We're looking at horizontal separations, verticals, mechanicals, sprinklers. Why not just put sprinklers in? What's the advantage of the sprinkler versus a 2-hour wall? 2012 code, 2015 code. What changed? We got rid of the need for 2 1-hour walls or a single 2-hour wall and said we only need a 1-hour wall if you have sprinklers. So my entire topic, if you have sprinklers, you can go get coffee. We're done here. So we want to think about now the guarded testing. If I'm looking at the condo side, I'm looking at firewalls, right? This is the difficulty of how to do this. We see this quite a bit on assisted living, independent living, where do we do our test, right? So where do I get this information? I open the code up. Do I find guarded or unguarded testing in the building code? Anyone? I mean, this room's full of experts. Do I find a description of guarded testing in the rules and unguarded testing in the rules in the building code? Yeah, not in the code unless it's adopted specifically by the code. So we want to know where those are. So guarded testing, if I sell the product, I love it, right? Lots of doors, lots of controls. I was talking to one of the mechanical, electrical guys about designing this and putting all the equipment in so everything runs perfectly, all of them at the same time. I don't remember who that was, but, right? Otherwise, I just go turn each of these on, or I have one of my employees in each house with the Motorola radio, just like 1995, right? We'll figure it out. So I go back and I start looking. There's this guy, Joe. He's done a lot of work. And oddly enough, the Gypsum Association recognized that. And they said, refer to field testing of compartmentalization methods for multifamily construction authored by Kodo and Joe, March of 15, right? So now I step out of that and I open up. I just Google it because it'll come up. And we can look at that, and magically they talk about the fire-rated assemblies and air leakage, the Halton and Prohl study, and the air leakage of fire-rated side-by-side area separation walls, multifamilies, the negative results for energy efficiency and comfort, and air leakage from one party wall to another party wall. Now, do I care about that as far as energy? Linda's got hers at 72, John's got his at 69. Do I really have much delta T? Odors and sound, right? So we get back to this interdisciplinary thing, odors and sounds, and smoke, potentially. So during that event, right? Particularly if the interview yesterday about who doesn't like the smell of cigarettes and who does. So if you live next to the smoker, you're going to care much more than if you don't. So we do want to be concerned with that, and we think those that were ahead of it looking at that. We looked at that and the studies in these spaces in the shaft wall. Now, in the study, what's missing from the attic? From the firewall at the attic, what's missing? That gypsum, right? If I have to put it there, it's not there. Do I need it? We'll talk a little more about that. But you know, I opened the study up and I said, well, they don't have it, then I don't need it. I did what they did. Right? So I will look at that interstitial space at the floor line and see the foam. I'll look at those areas of air leakage. I'm going to work on my details. Now, these condos are staggered horizontally. Will that create more issues? Yeah, I start separating the wall. Now, we talked about the vertical wall. What about the horizontal wall? Does that have to be 2-hour rated as it extends past? Yeah, the reason is quiet. Some people say, yeah. Some people say, I don't know. Really, a 1 hour by code, I could decipher that as a single 1-hour wall. Once I pass the other unit, some municipalities will say, no, Ed, if it's under 4 feet, I want 2 hours. But something I should address with the architect. And what about the civil engineer? Yeah, probably so, right? We're staggering the units. So again, that dang civil engineer, we just thought we got rid of them once the grading and drainage was done. Now I got to keep bringing them back about my property lines. And we're looking at, and now aerial barrier presented, and I appreciate this, and this is where Robbie and I started talking about the Thrive study and the rule, if I have to pick that pen up, I got a problem. So let's design and build so we don't have to do that, build that compartment. And we did look at this. Now, will the air barrier system reduce the propensity for fire movement? It will, by the way, if I can seal those holes. It's not going to hurt it. Is it tested? Can I count on it? Right, so I'm going to have to do another round of tests, and maybe they can make this, you know, so it'll expand during the fire. Just some thoughts for somebody who wants to patent the product. If I could convert this into helping my fire assemblies, be great. But nice deal. Air changes, definitely. This is out of the Thrive study. Again, online, you can pull it. But some big changes through those sill plates. Lots of leakage in standard multifamily. So we talked about the structural engineer. What's the tolerance on the sill plate for the concrete under the sill plate for undulations? ACI 117. What am I allowed? Plus minus 3/4 of an inch. Yeah, that's a lot. But we have sill seal, so we're good.
How many layers?
For my clients, yeah, they forget it anyway. So, and then the C channel at the base, it needs to be sealed as well. So we have a number of things that helps with sound as well. And I won't jump through all these, just so you know they're there. And we jump back into the other study. We look at the analysis and recommendations prior to that study. And it's pretty similar findings in regards to what we can do to minimize air leakage. And again, I do this because we're dealing with the same wall. So I want everyone thinking both ways. And that does show a great thing with the jogs and the attempts they did trying to airtight the jogs. So thank you, Joe and crew. It's all out there, right? We need to pay attention to what's already been done and try not to repeat the mistakes of the past with that. Yeah.
Air Justin wasn't happening, the air wasn't going from unit to unit. The air leakage from outside is traveling through the shaft liner wall, assembly through that wall next to the
Yes, remember you have that 1-inch space, you have your shaft liner, airspace, beauty wall. So this is in between, on the unit side, in between, and up to the attic, right? But my point being that the AeroSil products that we can see here, they are filling those gaps. So if I can get those gaps to fill, that's a good thing.
eyeball, not your gap between the framing and the strap line.
Correct. Yep. Yep. So we can see the impact of that, and we just get to what Robbie's talking about, is where is our airflow, where's it coming from, that interstitial space back in. So if I can close some of those up at the drywall layer, the membrane, I'm going to reduce it outside or inside my building, but from coming outside, also through the fire blocking joints themselves, if I can get there. And we look at the one on the right. Can I get my fire blocking in there? What can I do? So first off, we'll start with what's the minimum airspace between the wood and the shaft wall? 3/4 of an inch minimum. That's the technical requirement. So would this pass? Probably not 3/4. If I look at the clip with the vertical H channel, how tight is the clip between the framing and the Dens glass? Pretty tight, right? So this would be a failed assembly. How do I fix it before the drywall comes? Start over, right? Start over. If it's a 1/2 inch, what can I do? Pursuant to most manufacturers, I can slip in 1/2 inch type C between the frame and the channels. If I can get 1/2 inch in there, I'm allowed to do that. So on the bottom, that's a nice 3/4 inch space. Nice straight stud. Who's gone to Home Depot or Lowe's lately? Can I get a straight stud? Short of the structural engineer. That's a joke, right? Pretty tough to find. So we look at this and we start looking at fire blocks, say, what can we do? So I put in that 3/4, I've got a nice space, I slip that in on the liner, I put the clip in. Now I see on that clip, I've got 2 screws in the wood and 2 screws in the H channel. What do you think? What's the manufacturer say? All right, we're going to talk about that. So as a structural engineer, I like more is better, redundancy. Right? I wear a belt and suspenders. That way, if one fails, I'm still set. I don't have my suspenders. I'm taking a risk today that my belt won't break. I've taken a risk. Right? So I look at that, and I look at the screw patterns. I look at the fire stopping. Now, what about the foam fire stop? Why is it not acceptable? Okay, hang on to that thought. We'll get to you, Robbie. We'll get to you. All right, we're going to look at that. What about the fire sealant at the clip? What do you think about that? Equivalent to a fire stop? We'll say that the sealant's fire stopping material. Let's just do that hypothesis. What about at the clip? Who likes that? Not a great application. How about if I have this from the top side down? Probably better, right? If I'm into the space over the clip versus trying to bypass the clips. So what we're after is to try to get this all to fall down on one side perfectly, right? I want this complete 2-hour shaft wall to allow for one townhome to fall in. Now, I have a question for you. If this works perfectly, as it appears to here, almost, will there be any damage to the neighboring unit? Water damage, smoke damage. Maybe the fire got up under the porch lid. Want to talk about a vulnerability of offset townhomes with porches? The fire can get up under that porch. So let's vent the roof and let that fire out. Just a thought. Just a thought. So, but that's what we're after, is to try to minimize. And notice I don't use the word prevent, and you guys can all lose the word prevent from your vernacular for the rest of your lives. We don't prevent anything. What do? We minimize the potential to an acceptable risk within our industry. We don't. When I'm a civil engineer, I design retention ponds, retention. I designed for a 100-year storm. Potentially, it comes 1% chance every day, right? Over the basis of a year. Right? I don't prevent a bigger storm. I'm just designing for an accepted criteria. What's the temperature of the fire that burned this unit down? What's the favorite answer? It depends. What was in the unit? Right? It depends. We don't know. So the laboratory testing, remember that key concept. So what occurs is co-derived risk, right? We're minimizing the potential for death, property damage, and really so the responders can safely take care of the fire. Right? That's our job. Who's a firefighter here? Anyone? I got one, almost raised hand there. 2. I'm not one. If I'm a firefighter and there's a fire in a wood frame truss roof and I'm in New Jersey, what do you think? Are they allowed to get on the roof? Right? We have buildings that are stamped wood frame truss on the outside, so the firefighters know. And there's some concept, I don't have it here, there's some concepts on the steel plates, whether the truss plates are melting during the fire. Are they detaching? Are they tested for fire? Is a wood frame truss for every building as designed tested for fire? Is there any rating requirement? All right, so just put that in the back of your head. I'm not going to talk about that anymore, but just, next time you're in an attic, start thinking fire. Start thinking through those pieces. By the way, when I say that, what happened to the wood frame, the truss plates in this fire? Nothing. Nothing. So some things to think about. So now we get to burn stuff, right? We're going to start testing it. Look at those assemblies. We're going to look at 5 shaft liners. Again, for everyone's sake, every one of my tests has worked unloaded. So that's a good sign of industry across the board. Why would I want to test all 5? Or equal. So can I substitute one manufacturer for another? The architect called out for U347. Can I substitute a U373? How do I do it? RFI, right? I send a request for information, and I see if I can change it. Now, why would the architect be hesitant to change it? Extra work. Are they going to get paid for it? It was easy to write by others, deferred submittal. You tell us what you want to use. But if I use the manufacturer's details, I now have to go back and review the new manufacturer, and I have to do the same diligence under responsible charge to make that happen. All right. So we're going to look at those. We're going to look at the ASTME 119. We're going to look at the responsive materials and assemblies to heat and flame under controlled conditions. By the way, I can speak at 285 words a minute if you need me to speak that fast so I can speed up and get everything done. So if you're in a deposition, this is a really good way to do it, right? So you just speak really fast. You're fully, everything's audible. They're taking notes. And then the court reporter kicks you. They don't like it, but we can push through. So if I go fast when I read, I apologize. It's a bad habit. So we're going to look at that for the responsive materials and assemblies to the heat and the flame under control for a specified time. And then we're going to do a hose stream test. And the hose stream test is to assess the impact, the erosion, and the cooling effects. It is not to represent the firefighter standing in John's attic spraying Linda's wall with the hose. That is not the test. Right? So if somebody tells you, well, that's when the firefighters show up, they want to make sure it's intact for the hose stream. That's not what this test is about. And we do get that argument to it. So we're going to look back at these walls, and we have to decide what it is we're going to test. So what was tested was the bottom right. Everything else is untested. Right? It's just what we do. It's what everyone else does. But they are still untested pieces in this wall to consider. So we'll look at this, the significant use. We want to look at the relative measure of the fire test response of comparable building elements under the fire exposures, not representative of all fire conditions because conditions vary with changes in the amount, nature, distribution of fire loading, ventilation, compartment size configuration, and heat sink characteristics. All fires are not the same. Right? So if I go to a site and I say I have a 2-hour wall, will it perform in 2 different fires identically? And the answer is no. It will not, right? This is a laboratory test. And we're using the UL rating as a laboratory test on a constructed assembly. So know the limitations of it and what we're doing with it. So we're going to go back in, we're going to build this, we're going to look at the degree and control, the passage of smoke and flame, the fire behavior, the temperature, the effects on all these pieces, right? That's what we're after. So we're going to build a test specimen. Our physical property, we're going to look at the ingredients. So section 5.1, the ingredients. And I have to write down my recipe. I have to write every part down. So you'll hear some experts say, well, the building code, particularly IRC, references a cookie recipe. And if you violate the code, so, a little extra sugar, not enough flour, I use baking powder instead of baking soda, will it still taste like a cookie? It might, right? It's untested, we don't know. So if you want to count up the deviations and then pass them because it feels good, the real question is, are we still complying with the alternative section of the building code, 104, is that 104.8? I should have everything memorized, right? Unfortunately, kind of the way my brain works. But we're allowed alternatives to the code if they are tested and approved by who? The building official, right? The HA. So if I'm going to substitute those construction tolerances in, I have to get approval for it. Okay? So we're going to look at this. We'll look at the test conditions. We're building the wall down at the bottom. Now, we'll note the sensor placement. We're going to talk about that. So we have sensors 1, 2, 3, 4, 5, 6, 7, 8, 9. Where are those located? Just looking quick at the photo. On the drywall. What's the temperature of the C channel, back-to-back C channel, or the H? During the fire. I was going to say during the room, it's how much? The temperature of the room, unless we get, reflectivity and I'm standing next to it and I'm hot. Again, structural engineer jokes. That's all I got. So we'll look at that. So one of the questions that comes up, remember in the attic, do I need drywall or not? Yes and no. If it's accessible, I need drywall. If I put my HVAC system in the attic, is it accessible? It better be, right? So if I change that condition, then I may need to cover those. If I don't, my opinion is I don't need the drywall. But what's the temperature? So I decided to put my Christmas tree in the attic. The real Christmas tree, because I'd like to reuse it. I just spray paint it green every year. You know what that's called? That's being green. All right. So I'm trying, Joe. I'm trying. So we look at that, and will people put combustibles against the shaft wall? Yeah. If we make the hole big enough, they'll get up there. Right? Do we have to have the scuttle hole in the attic? If it's above 30 inches. If we have more than 30 inches, I have to have a scuttle hole. And who's the scuttle hole for? The firefighter. So they would never take a chainsaw and cut a hole through the top. They will always politely knock on my door, go up the stairs, and then get the ladder and go up my scuttle hole. They're not going to ruin my roof looking for the fire. Right? I gave them access. It should be good. So we want to look at those sensors. We want to make sure we construct the walls. Now, I can follow the recipe given to me by the manufacturer. My study is about what? About what to do when it's not done right. What is the construction tolerance? So I'm going to look at common deviations from this. I want to make sure I categorize and document the construction, my recipe, and then I look at the problem areas. So we have the clearance to wood. We have the fire blocking, which we'll talk about, the foam. We have the stagger, which I can't test, but we do have that question. Is it as easy to extend the 2-hour wall past my jog? I tell my builders, why would just extend the wall? It's so much easier than trying to build a 1-hour wall past the 2-hour wall. Just make life easy on me if they can. What about at the attic space? So I'm going to bring the trusses in on top of this. So I ran that shaft wall up there. What do I have to do to the top of the shaft wall? I got to make it match the bottom of the roof sheathing. So a little coordination again, that dang architect and structural engineer, just build me a perfect box. I'm good to go. We'll have to work at it. So we have mixing of products, breaches, use of H clips instead of back-to-back Cs. Lack of clips, lack of floor ceiling closure, lack of proper fasteners or too many, and then the lack of the airspace. We're going to look at what variables matter, what information is available from the manufacturers, and I note regarding their exact testing. So what's the chance my 5 manufacturers are going to give me their actual test? If I have a good lawyer, they send a subpoena, and we get it under confidentiality. And then we have so many days to destroy it once the case settles. Never be seen again. It's not publicly available. So when you get into these tolerances, and I want to know what happened during the burn, that's where this became very difficult, and why we started burning the walls. We just couldn't get theirs. So mixing of products, what do you guys think? How about that thermoply? Where's that one located? That's the 4-foot jog out at the front porch. So is it okay to switch National Gypsum and Densglass? Don't know. Not been tested. I don't know. What about the breach in the back-to-back Cs between the product? Not allowed. How about that I can push the edge of this product and walk in the neighbor's unit? Probably not great. Do you see any clips? But the code official approved it, so it must be okay. What? Wrong? Well, that's my first line of defense. Right? Same question I get every time. But where's the code official? They approved it. They saw everything. How about third-party inspectors, QA? If they saw this one, how do I know which ones they saw? Subpoenas, lawsuits. Nobody wants to just give me their file. Right? I don't know why. Just fess it up. If you did your job, do you care? Right? Makes everyone a little nervous, right? On that. So what about the floor truss, or I should say in this case, the ceiling joist coming to the wall? What's missing? So I went up for the firewall. Who feels good about a 2x12 with no blocking? Who wants to walk on it? I think the hardware may help. You got a little bit of lateral load at the bottom. They put the hold downs in, so when the roof blows off, the rafters will still be there. Right? No connection. This is the edge of a diaphragm. I have to be connected for my diaphragm. How about the right-hand side? No gable end truss. These are townhomes. So I have no gable end truss. I've got the roof diaphragm across 5 or 6 units and no intermediary gable trusses. Structurally, this won't work, and it's not allowed by code. But again, it got approved, so we're good to go. Right? We start looking up in those spaces. We do see clips. We do see diagonals on the right-hand side. We don't on the left. Filled fabricated gable end versus a supplied truss. So I get the truss drawings. I verify that they did, in fact, include the lateral load components. I start looking at those interstitial spaces. Now I'm trying to do an inspection. What's happening at the top of the panels where it meets the roof? How do I know? I got to get up there and look, right? So maybe bring a borescope. How about I do the inspection while I tell the builder I want to do the inspection before the sheathing goes down? Remember, the gable's coming first. So I have a chance to make sure the C tracks are in on there. How about looking down the wall? How far can I go without fire blocking? 10 feet. Right, same rule as always. Why 10 feet? How big's the test chamber? 10 feet, 10 by 10. Problem solved, 10 feet. Right, so I shouldn't be able to see spaces like this. How about at the top at the ridge board? That doesn't look like it quite makes it, does it? It's a good thing fire stops at 30 feet. I think I read that in a book somewhere, right? Size of the test chamber. So what about behind the beauty walls? What am I missing? Maybe. Airspace and clips. Now, some manufacturers will look at a diagram are 10 feet, some are 5 feet, some are 39 inches. Why 39? Tests were done in inches because 40 didn't work. So they retested the wall, moving the clip 1 inch, and it worked. They missed the first test by 2 minutes. They made it to 1 hour 58, not 2 hours. So they reburned the wall, moved the clips 1 inch closer, and it passed. I'm sure it was the clip. I'm sure of it. So that's where we get, as I mentioned, the beauty wall does give us some protection It should not be discounted, but the beauty wall's not been tested in this condition. So we get up and we start doing our inspections. We start looking for those voids, those breaches. Now, am I going to test this in a fire assembly? Am I going to burn this wall? Not this actual wall. I'd build it in the lab and burn the one in the lab, because if I burn this one, the owners get mad. I'm not going to build a wall with breaches. Breaches are not allowed, right? Not something in a tolerance. Breaches are 0 for my tolerance. Fire will pass through. Accessibility. Is that attic accessible? Yeah, that's pretty accessible. Are people going to use it for storage? Yeah, they bring their OSB up through the big hole, make the hole small, they can't get up there, right? But once that's made, they can get in. So I have no gable end truss, I've got no drywall on there, no clipping, all sorts of problems on this. Now I look at those fasteners, I'm going to pull those fasteners out, I'm going to verify the size of those fasteners, wood screws into the wood frame, pan screws into the channels. And this is not me doing the test, this is one of my competitors who then is cutting the shaft liner to validate that 1-inch shaft liner exists. One forensic test I wouldn't probably do personally, right? It's a 2-inch wall, 2 1-inch liners. It fits in the channels. I can get in both attics. I don't have to cut the wall open to do it. But they did, and then measuring the airspace. What about the horizontal clip? Is that okay? We'll talk about those clips as well. Horizontal, vertical, all sorts. We'll look at the breaches. Now, the manufacturers and Gypsum Association provide me instructions how to deal with those short channels and the breaches. So you're in deposition, and you say, I'm only going to allow what's been tested. Has this been tested? Right, so we already have some tolerance allowed. Fairly enough, we know we're not perfect. Right, so we want to look at that. We want 1 1/4-inch wood screws. We want a 3/8-inch pan. And by the way, we only want 1 of each. You only need 1 of each. That's it, right? We look at the spacing. We have 10 clips under 23 feet. If we're less than 54, we go to a 5-foot spacing to lower floors and 10 foot in the attic. If we go to 66 feet loaded wall, we move down to 39, right? So more clips. Why do I want more clips as I load the wall? What happens when I stand on that 2x12 in the attic? What's it want to do? Right? In a fire, what's going to happen with one side of this wall? We have 1,800 degrees on one side at one point, and we have not that heat on the other side. We have ambient. Yeah, it's going to expand, and the wall is going to suck in. Right, so this is a structural issue. So we're going to go back to the expert testimony. And note they always start, we've already gone over this because the lawyers like to ask questions over and over. And there are very consistent certain aspects. Those aspects are consistent with the design that we understand was constructed. So I think it's very likely the balance of the units are constructed in a similar fashion. What's that referred to as? It is speculation, it's extrapolation. I've extrapolated my findings to unknown. So I've got 2 known points, and I draw a line, and I want to answer a question about what's in between those points. What's that called? Interpolation. Extrapolation, extending the findings outside that, I don't know. Not allowed, right? So we'll start there. Okay, you're not sure how long it will last. I'm talking about fire duration. It does not matter as long as it's less than 2 hours is the minimum code requirement. If it's less than 2 hours, it's a failure, is what he's saying. What if it's 1 hour, 59 minutes? It's less than 2 hours. And if that's the case, you believe it's a life safety issue with the construction, separating the dwelling. And what do you mean by life safety? What is safe defined by the building code, and that's the minimum standard of safety. These do not meet the standard. So in my opinion, it's life safety issue. Okay, so I'm an engineer or architect, I make that statement. What do I have to do? I have to notify my client of a, by the way, potential life safety issue. And they better get the heck out of there. They could die. It's only going to last 1 hour, 59 minutes. You could all die. If it was 1 minute longer, you'll all live. Seems reasonable, right? So the testimony being provided is that if we don't deal with this, we have created a life safety issue to everyone in the building. A lot of people say, are we sure? How would I know that if I have no testing? That's the reason for testing. You guys get blower doors, I get a furnace. So if I call it a life safety issue, what's it cost to repair that in a finished townhome on both sides? I have to skin the inside of the unit, recreate an airspace, fix everything, rebuild the interior. Why are the lawsuits so expensive? So one of the questions, what's the impact of all this furnishing on the wall itself and the finishes? It may make it better, it may make it worse, right? I'm adding stuff that can burn, right? It can burn at certain temperatures. I may make it worse with finish and furnishings. I may make it worse. There's some great NFPA videos of college dorm fires where they make fake dorms and they spill a bottle of nail polish remover with all the pizza boxes. Really fun things to watch. If you go to NFPA's website, just fun, right? Get a good beer and say, okay, my kids are in college now. Are they being organized and cleansly? And then you call your kid and say, send me photos right now. And not only of your unit, of everyone's around you. So we need to look at that. So we want to fix that airspace, and the engineer or the architect working says, I saw the airspace in the attic and it was less than 3/4 of an inch. Therefore, it is less than 3/4 of an inch everywhere. And you must gut the unit. I'm telling you what's happening in the industry right now, why we're involved in this. That's what's going on with it. So, ipsy dipsy, it is because I said so. Liar, liar, pants on fire. I thought it was funny, right? But we're looking at that expectation bias, reaching premature conclusions without examining all relevant data. I never tested those lower walls. I never opened them up and looked. How do I know what's down there? And they say, well, because the truss is closer than 3/4, therefore, all the wood frame below it's closer than 3/4 because the same framing sub put all three pieces up, first floor, second floor truss. So therefore, they must have kept the same spacing the whole time. Who buys it? Yeah, well, hopefully no one does, because all they had to do was go test, right? Go out and test your hypothesis that is the case, it's always the same. See if it is or not on that. So our confirmation bias, the different hypothesis may be compatible with the same data. I say no. I have the same data they do. I'm saying no. They're saying yes, right? Experts, we get paid. That's part of being an expert, I think. Somebody gets paid. The mixing of the products, at this point, they asked for documentation from the builder demonstrating code-compliant ASW system was installed, considering the gypsum panels are not acceptable for the ASW design specified by the architect. They substituted product, therefore, they gave a choice of ripping all the buildings down or to go ask the building department and the architect if it was okay to substitute, specifically the architect. What's the architect going to say? I wasn't called out for inspections. I didn't know. I don't find it acceptable. Why does the architect say that? They don't want to be in the lawsuit. What's the building department going to say? Not our problem, right? Really prevents a difficult. Now, he does note that we can, if testing is available, and my response was, well, we can test these walls and see if they're the same, right, for that condition. So they started, it's our opinion, so I highlight because it's their opinion. Is that fact? It's our opinion that the code required 2-hour wall rating is compromised when the construction of the SW wall is closer than 3/4 of an inch. Can you make that opinion without testing? You can make any opinion. Is it supportable? What if I call the manufacturer now, what do they tell me? You need 3/4 inch. Why? That's what we tested. Our test was for 3/4. Why 3/4? Why didn't you test 11, instead of testing 12/16, why didn't you test 11/16 and give me 1/16 of tolerance? Why didn't you test 1/2 and give me 1/4 inch of tolerance? Why didn't you test 3/8 and give me 3/8? And they said, well, we tested 3/4. Okay, so we don't have that information. We're gonna have to find that. Now he notes that the clips and the failure will cause the wall to fail, cause the failure of the firewall, and during the fire event, the aluminum clips on the fire side will disconnect and everything will fall down. We'll look at the clip spacing. Maybe. We'll see. Oh, and his description in his report, I just like this, because he notes person in attic would not be able to see the clips mounted to the head plate below. So he's expecting someone to go up and look down the wall and look for the head clips, but they're covered by the fire block. Right, so I said, well, then how do you know what's below? If they can't see it, how would you not? How would you know? Right? Go cut the lower walls down on there. And then we also then use back-to-back C channels, and we looked at the installation throughout the project. Note, they say noted to occur throughout the project. How many attics did they inspect? So say I have 100 townhomes. How many firewalls do I have? Maybe 99, right? If they're all together, right? It's always townhomes -1, right? Depending on the building. So how many is an acceptable sampling for discrete sampling? We don't use the word random, but discrete sampling. I could get paid to get in everyone's unit. That's preferable if they allow me. Right? Enough. Enough, right? What's enough? It's my opinion that was enough, right? If I saw the same thing in 10% in every building, I'm probably feeling pretty good. If I saw differing conditions at every third building, I'm not feeling so good. If I find out there was 7 framing subcontractors, I want to know which buildings they worked on, because I've got different people, different trades. Maybe the super got fired 6 times. Happens, right? So we want to look at those pieces. So we're going to get that wall, we're going to build it. Now, the lower photo, one of the questions is the cellulose insulation, will it burn? Try it up against those metal clips. Will it burn? What's the thoughts? Okay, so I got 1 burn. Okay, let's hand up. How many burn? Char, I'll take char as an acceptable answer. Okay, so maybe 30%. So we tried to build an attic next to the firewall. Was this in a standard test by the manufacturer? No, right? But we're trying to see, one of the claims was that combustibles are placed against the H channel and everything will ignite and the neighboring unit will burn down just from the heat transfer. Remember the T to the 4th heat transfer? The equation went up. I didn't put the equation in, but the equations are cool. So it was an enjoyable slide for me on that. So we're going to look at that firewall. We're going to make our recipe, and I'm going to put over the metal stud sensors because I want to know what is the temperature of the metal stud during the fire. Right? I want to answer the question, will it result in combustion of my Christmas tree that's leaning against it? The one I keep spraying green. Same tree. So I'm going to look at that. I'm going to know where I got everything, the date it was received on, where it came from. What about temperature and humidity? How do I replicate temperature and humidity? Should this be green wood? That was last night's presentation. Wet wood. Wet wood's good for this, right? Let your roof leak, get it all wet. Reduce your fire potential. Right? So I want to make sure that it's come to equilibrium, right? So if I'm buying it at 15%, is equilibrium 9, maybe I want to dry it out, acclimate it to its in-service. Right? Now that also means in the attic, I need it to be 180 degrees or 150 degrees because I'm in Arizona. So maybe I got to heat up my burn lab. not done. I'm just saying, if I want to pick one, be careful of the poisons we take there. So we do our mock-up of the wall, we look at the detailing of those, and we look at those conditions that they're complaining about, and we're going to recreate those conditions. So we started this with, I didn't know, so I started with a 3/8 inch airspace because I did not know. And nothing happened. I was able to get my 2-hour rated wall assembly. So I said, okay, push the studs on the next burn, let's push them right up against the C channel. We'll look at the results of that. The sensor over the metal track, good or bad? It's good because I want to know, but what's bad about trying to put a sensor on a 3-dimensional plane? It's tough, lots of convective issues. And the lab told us, Ed, this will never work. Well, why not? Because we're going to have all these problems with it. Well, what did the manufacturers do? We can't tell you, that's proprietary. Right, so mine's a scientific experiment. So we go through, we put all those together, we burn different ones, we tried different ways to deal with the track and the sensors and keep that, and we did have a lot of problems with those. Then we're gonna go to the furnace and we're gonna burn this sucker. And we're gonna burn it, it's not at 1850 the whole time, right? We start 1,000 at 5 minutes and we work to 1850 at 2 hours. So that's the end goal. So again, in a real fire, what's the temperature? Yeah, whatever it is. It could be more, it could be less.
Where is that?
This is inside the furnace, on the fire side of the wall.
Not your sense.
No, not my sensors. No. The chamber temperature. And so we light that up. We're 3 minutes in. We are 10 minutes in. Has the wall fallen away? Are those clips melting? And the whole frame just fell down? It's all burning in place together, right? So the aluminum clips didn't just melt and the wall falls in. So we're at 20 minutes or 50 minutes, what do we see? Kind of cool, right? The wall's buckling inward, pulling itself inward. What's that gonna do as well as the difference in heat? It's gonna try to pull the non-burn side inward as well, right? So we do have a little bit of structural transfer. 20 minutes in, we have nothing happening on the outside, kind of boring, right? They're talking about last night's game, waiting for something to happen. Anytime something will happen. But on the combustion side, very cool. Well, sorry, very hot. It's very cool. So at about 27 minutes, depending on the wall type, 27 to 35 minutes, we have full consumption. Everything's gone. Right? The wood frame is gone, the attic's gone, the Christmas tree is gone, right? So what happened in that first 30 minutes was really key to kind of get an understanding of where the importance is. Now, am I going to be in my unit next door for 2 hours when this happens? Hopefully not, right? This is a tested assembly for 2 hours. So the testimony that 1 minute is a life safety issue, I'm going to have to call bull on. That's not what we're after here, right? We're after the ability of a system to resist a laboratory experiment, so to speak, for that duration as part of our safety of our passive designs. So all results, again, 25 to 30 were out. It did not matter on which one we used, right? Because we're burning wood. Now, deflection mattered. So this was without clips. We just had the bottom and top tied, 10-foot chamber, no clip. And so this is our failure, so to speak, by deflection, not by a loss there. And guess what happened with the insulation? Nothing. Now, granted, this insulation shelf's at the bottom of the furnace, not the top. Could I have higher temperatures at the top of my furnace? Probably so, right? A little bit of stack effect. We look at the edge of chamber. We look at the review of that edge of chamber. And not seeing a whole lot, but we do get some puffing. Puffing is not a failure. A little bit of smoke will puff out. Wasn't considered a failure for that. And then what we're looking for is charring, right? So that's the burn test. Now we need to go back to the hose test. And the hose test, really late 1800s, 1918, and then 1922, the National Board of Fire Underwriters publishes this. And there's the firefighter standing straight across spraying the wall. right, the hose stream. Is that going to happen at the firewall during the why they put the fire out? No, right? This is not for that. So we did the test at 2 hours. The hose stream test only has to be done for 1 hour wall. So we burn for an hour and then we hose stream test. I don't want to pay for 2 tests, right? It's my money or my client's money. If I can pass a hose stream at 2 hours, I do not have to burn another wall. Right? So we're going to try, we didn't get that one to pass. We did get the others to pass. Right? So that, again, if the one that did pass, what did I have to do? Reburn a wall for 1 hour, same recipe, and do the hose stream again.
Failure.
Water penetration to the other side. Good question. So the question, what is the failure of a hose stream? Water penetration to the other side. So 120 minutes, we take it out, we burn them, and then we run that hose stream test, and we can see the pre-test and the post-test. The hose stream pocked it up a little bit, but it did not breach the wall, right? So we have someone not standing on the other side. Nope, no water's coming through, no water. And this is the first layer of gyp. The second layer of gyp is, as you saw in the photos, was still intact, right? We don't see anything on one layer of gyp. So we really still have 2 layers of gyp. And so the hose stream's really hitting one layer directly, and then if it passes that layer, it still has 1 layer of protection. So we run that. And when you do that, you got to get in that crouch position because it's more fun. And make it active, make it active. And so we had those successful tests, the unexposed side, no water penetration coming through, good tests. So just showing we did those all. So the hypothesis is disproven. We have from that, the wood frame, it was going to char. So we said, okay, take all the drywall off and let's examine the wood frame. We don't inspect, by the way, we examine. Because my insurance company says don't use the word inspection because it's a higher level of risk. So we examined the wall or observed the wall. We did not inspect it. Another word to lose. And we don't have charring. And we don't even have charring where the channels are. Even though the channels got that hot, it did not char the wood. All right, so we look at that, test observations going on. This is what we'd love to get from the manufacturers that we just have not been able to. But just look at it, the playbook during the test of what's going on with this. We note the at 1 hour 10, the 1 hour 10, we have deflection at 2¼ inches on that wall. So quite a bit, right? That's quite a bit of deflection. Not necessarily failure, but failure by amount, but just moving inward, right? So we look at the heat channels, and we're looking at number 2, number 7, number 8. And we can see number 2, we're at 647 degrees, number 7 at 504, number 8 at 719. Why such a variation? Remember how difficult it was to get the sensor tight against that product. 6x6 sensor, and I got this little channel. So I got convective currents occurring. But at least it gave me some data to that. Everything else, this would pass on that. We look at that and we see that curve at the front end of that, and we see that wave. Why do I see that undulation occurring? Remember what happens in the first 20 to 35 minutes. What's happening on the other side? The wood's burning, and then it falls away. Guess what? Now I've got a nice temperature rise because I don't have combustibles. Right? So look at your day and say, why is that occurring? Well, that's why. What about the upper right hand with the unexposed side? What happened with that gold line? It fell off. Just like the lab said, told Robbie and I, it's going to fall off. Well, do it anyway. You know, do you want us to put it back on? We say, yeah, just go screw it back on, I guess. It's just there for science. It's not part of the tested assembly. It was just there for the science of it. And we look at the unexposed temperatures, pretty decent in that regard for all the sensors. And we summarize those tests. In this case, of those 5, we note that we had 3 pass at that point. Of the 3 we did pass the hose stream with a 2-hour burn. Pretty impressive for the industry. 1 did not.
I just need some context. Were you doing this because there was already a fire or because
No, potential life safety issue, $28 million. My client would have to pay $28 million for a potential life safety issue.
Who identified
Plaintiff engineer.
doing an inspection?
Doing an inspection, yeah. No, after everyone moved in and the lawyer showed up. All right, so I'm at 5 minutes. As I mentioned, I'm going to leave, you guys have all this. The air sealing information here is from Robbie. So at lunchtime, you grab Robbie and you're going to walk through those strategies. Remember, we are going to try to combine all this together on this. So again, Robbie's here. And since Robbie helped with me, I'm going to pass through so you can see all his pieces here. We're going to get to the conclusions of that. We obviously need to address the tension between energy codes and fire codes. What is tested for burn, what is not, what is part of the assembly, what is not. But to answer the foam question, and I'm going to get to there, a couple things. So City of Denver, this is now in the code. I don't have to extend the shaft wall all the way to the outside wall. I can block it. Denver did this, it's now in the code. So this is why we want to work with the building departments on how do we deal, now when this is offset, even more important, how do we detail that piece, right? So to the sealants, and we go all the way back to the 2005, the 2012, the 2015, by Joe and his team, we need to know the importance of sealants and are they fire rated? And the fact is they are. And again, Robbie's here. He can go in depth about the testing they did, who paid for it, who got the results because they paid for it, right, Robbie? Who gets to promote it? But they all passed. All of them passed, right? Right. So more were tested, but 5 are listed, and those are the paying parties. So they get to do that. But that's good news for all of us, because we're seeing our builders just go get, fire foam and fill it. And the engineers and the architects that are bringing these claims, their argument is those are untested products. They're not part of the assembly, and you have to rip all that foam out and put fire blocking in. So we put foam on our tests every time. Nothing ever happened. We could not get it to char. It didn't ignite. Nothing happened. Kind of boring. Yes. It costs between $15,000 and $40,000 per wall. And once the lawyers got involved and found out we burned the walls and they deposed the lab participants, all of them, the price went up. And the desire to work with me went down because they said we didn't want to be deposed. And the depositions were tough, but what it did highlight is things like the humidity and the wood moisture content. One lab didn't record that at the start of the test. So they said, well, you can't count on that test, Ed, because they didn't take the reading. They were not in strict compliance with the requirement. Therefore, that test is void. And I said, I didn't burn these walls to get a rated assembly. I burn these walls as an engineer to understand what's happening. That's what we do. So, I didn't do this, but I have used this successfully in repair projects where I go to the building official and say, okay, they made this life safety claim. I've been hired now to repair it. And I don't think you have to repair it, and here's why. And guess what the building officials have done? Laughingly said, you're going to rebuild a wall because they missed a quarter inch of airspace? You're going to gut the unit for a quarter inch? I'm not. We used to put in, and I used to write these reports, you violated airspace, you must fix the wall. And typically that was intermescent paint. We would just go up in the attic and spray intermescent paint across the whole thing. Done. But we don't even have to do that now when we're dealing with certain items. The clip spacing did matter. We saw the inward deflection. Clips at 5 feet are the right answer. Mid blocking, right answer. Structure's good. And it should be a diaphragm wall anyway. It should be the end of the diaphragm. So connect that. But clips mattered, no breaches. The other stuff they brought up, I couldn't get any of their hypothesis. They all failed. Right? Do they believe me? Now, we're still fighting it. Again, my tests are proprietary, my client, I showed them to you here. I've got one other firm now who's doing the same for another builder. So I've had some great conversations with another firm regarding these tests and how to deal with them. But we're seeing this more and more across the US. Anywhere there's a townhome, this is a potential lawsuit. So, yes.
The question is, what triggered plaintiff engineer even being here? And then
Because it's an easy claim, right? And again, I used to make it. I'd walk up in the attic and say, that's a $10 million claim.
the predatory lawyer. I understand. Who started that process?
Well, so a lawyer asked me to go in the attic. That started the process. So one of my last joke for Joe, when I started doing crawl space investigations, which is really where Joe and I met, I realized after 3,000 crawl spaces that my career was going into a hole. So we got up in the attics and we saw this and said, you need clips at 5 feet or any clips. You need terminations on the shaft wall. You need fire blocking, and it's not here. And so we report back to the lawyer saying, this is what I saw, and they file a lawsuit.
I think why they call us there.
Because they're lawyers that get paid contingent for lawsuits. They make 33%.
That was their business model. They were looking for.
But was it a homeowner who was pissed off about the kitchen?
It's always, my whole job's about people being mad at people, yes. That's what starts it, is typically my builder fails to provide a good warranty claim. And they piss somebody off, and then they turn over the declarant control.
If I could, I think you're missing a piece, is that hopefully no one in this room. There are firms that go out looking for new condos, new buildings, to inspect them, to find these kinds of problems, to then create work.
Yeah, and I'm just going to respectfully disagree that they tried to find the problem, but that is their business model. There's also, you'll hear that, they go and gut somebody's unit and find all these issues because they bought a unit and gutted it. Completely BS. Complete BS. It doesn't happen. I've been doing this for 30 plus years. Never once have I been to gut a unit without a claim. I've never had an attorney buy a unit and gut their own unit. So if you've heard those claims, I'm just telling you. And I work both sides. What?
Like, wow.
Well, by the engineer code of ethics, if I have a life safety issue, potential or immediate, I have to notify my client. If my client doesn't want to hear it, I have to notify the building department. In the case that I have more than one potential, I've got party unit A, party unit B, party unit C, and D. I have an HOA, I have a developer, and I have the jurisdiction. And so the honest thing is, I better send that report, because if I truly believe this is life safety, I have an ethical obligation to deal with it.
So in this case, what did you do?
We notified the building department. I'm working for the builder in this case. So my builder's aware of it. And ultimately, once we got the testing done, you know what I told my builder? You need to add clips. This is a potential life safety if there's a fire. And if we don't get this resolved and there's a fire, we'll have new lawsuits.
Your license doesn't care who you work for, though, right?
I don't care who I work
You have
for.
to say what you have to say. The bad news. Either way.
Either party, right. Well,
You
yeah,
have
I
to
can't
tell the truth.
tell the truth.
whole truth and nothing but the truth, so help you God.
That's correct. And it's tough when we're not working for the owner of the property, the HOA, the individual owners. It's tough because I really have no right to go tell them. We get the plaintiff report and we're responding to the plaintiff report. So the real question there to the plaintiff engineer or architect is, did you inform them? So first off, and we get answers on both sides. Sometimes the answer is yes, we did. When I do it, I'm working plaintiff, I have a HOA meeting. Everyone comes, or we do it on Zoom, and I go through my findings. And this is a life safety issue. I'm going to make you aware about it. If you want on your own to get it fixed right now, that'll be on you, and hopefully we can recover the fees in the lawsuit. But it's a potential life safety issue. I've got one property, we're doing fire drills every 30 days, just like they're in school. So I've got, this is in Austin, I've got 200 residents. We set the alarms off. They all have to run out of the units to the muster station and get accounted for. What else am I going to do? I have no fire. In that case, I have no firewalls, no smoke barriers either.
Wow. Holy shit. Any more questions?
I just have a quick comment. First of all, thanks a lot to Paul Duffy and the Foam Association, because they did the actual burning and testing to allow foam sealants to be used in addition to the fire blocking. It's not a separation, but they're all 5 assemblies, these listed assemblies you can use, you can now air seal because of the work that they did. And it's so important because those walls are not true adiabatic walls. There's so much air moving in those walls and the temperature isn't equal across that wall. So you have tons of heat loss and other things going on there. So just thanks to that work that they did.
Yeah, thank you, Robbie.
These guys are going to be available beside the fire pit today to answer further questions.
Yeah, I've got to catch a plane to Denver at this night, so I'll be around through the afternoon, but unfortunately not later today.
Well, I want to thank you. You burned the, okay, no more jokes. Thank you.
Yeah, thanks everyone.